There's an animal in the ocean that punches with the force of a bullet. It sees colors you can't even imagine. It moves faster than you can blink. And if you put one in an aquarium, there's a decent chance it'll just punch through the glass and escape. And I need to tell you up front, nothing about this animal makes sense. Not its name, not its body, not its abilities. And the more you learn about it, the less you understand how evolution even produced something this absurd. But before we go any further, we need to address something fundamental, something that calls into question everything you think you know about this creature. The name is a complete lie. Even though it is called Mantis Shrimp, it isn't a shrimp, and it's not a mantis either. If you look at it, sure, it kind of resembles both. It has the general body shape of a shrimp, long, segmented, with that curved tail. And its front appendages fold up like a praying mantis, those distinctive raptorial claws that it keeps tucked close to its body. So the name makes sense visually, except it's completely wrong. The mantis shrimp belongs to an entirely different order of crustaceans called stomatopods. It's not closely related to shrimp at all. The resemblance is just convergent evolution, nature accidentally designing two different things that happen to look similar. It's like calling a dolphin a fish because it swims and has fins. Technically wrong, but the name stuck anyway. And here's where it gets even weirder. There isn't just one kind of mantis shrimp. There are over 450 species, and they don't all hunt the same way. They don't even use the same weapons. Evolution split them into two completely different strategies, two different kinds of deadly, the smashers and the spearers. Imagine if humans evolved into two groups. One group had sledgehammers for arms, the other had spears. Same species, completely different tools. That's what happened with mantis shrimp. Smashers have club-like appendages at the end of their arms, thick, heavy, reinforced structures designed for one thing: smashing. They hunt hard-shelled prey, crabs, snails, clams, anything with armor. And they don't try to pry the shells open. They just hit them. Very hard. The shell cracks. The prey dies. Simple, brutal, and effective. Spearers, on the other hand, have sharp, barbed appendages that unfold like switchblades. They hunt soft-bodied prey, fish, worms, anything that moves fast and doesn't have a shell. They don't smash. They stab. The spear shoots out, impales the target, and drags it back. Fast, precise, and lethal. Same family, same ocean. Completely different evolutionary paths. It's like evolution couldn't decide which strategy was better, so it just said, why not both? And now we have two versions of the same animal that hunt in completely opposite ways. One's a brawler, the other's an assassin. But here's the thing. The smashers are the ones that really break the laws of physics, because what they do shouldn't be possible. A mantis shrimp's punch reaches speeds of around 23 meters per second. That's about 50 miles per hour, from a standstill, in water, with an arm that's only a few centimeters long. To put that in perspective, that's faster than a bullet from a .22 caliber pistol. A tiny crustacean, no bigger than your hand, can throw a punch that moves faster than some firearms. But speed is only part of it. The real insanity happens when the club hits its target. When the club strikes, it moves so fast through the water that it creates an area of low pressure behind it. That low pressure causes the water to literally boil and form vapor bubbles. This is called cavitation. And when those bubbles collapse, they release an enormous amount of energy, enough to reach temperatures of around 4,000 degrees Celsius. Hotter than lava, hotter than most flames, in the middle of the ocean, and it gets worse. When those bubbles collapse, they also produce a flash of light. This phenomenon is called sonoluminescence, and scientists are still trying to fully understand it. But the mantis shrimp doesn't care about the science. It just keeps punching. So here's what happens when a mantis shrimp hits something. First, the club strikes the target at bullet speed. Then, a fraction of a second later, the cavitation bubbles collapse, and hit it again with a shockwave of superheated energy. It's a 1-2 punch. Literally. The prey gets hit twice from a single strike, and if the target happens to be aquarium glass, the glass loses. There are documented cases of mantis shrimp in captivity punching through the walls of their tanks. Aquariums have to house them in special reinforced enclosures because standard glass won't hold them. They're not trying to escape, necessarily. They're just defending their territory. And if the wall of the tank happens to be in their territory, well, the wall has to go. But this raises an obvious question. If a mantis shrimp can hit hard enough to shatter glass and boil water, how does it see what it's punching in the first place? The answer lies in its eyes, obviously. The mantis shrimp has the most complex eyes in the animal kingdom. And I don't mean that as hyperbole. Scientifically, objectively, these are the most advanced visual systems ever discovered. Humans have 3 types of color receptors in our eyes. We see red, green, and blue, and our brains mix those 3 channels to create the full spectrum of colors we perceive. Even birds which have excellent color vision usually have 4 or 5 receptors. The mantis shrimp has 16 different types of color receptors. It doesn't just see the visible spectrum, it sees ultraviolet light, it sees infrared, it sees polarized light, something humans can't detect at all without special equipment. And here's the kicker. Scientists initially thought that with 16 receptors, the mantis shrimp must see an impossibly rich spectrum of colors, far beyond anything we could comprehend. But when they tested it, they found something even weirder. The mantis shrimp doesn't mix its color channels the way we do. It recognizes colors instantly, without processing. Each receptor fires for a specific wavelength, and the shrimp's brain just knows what it's looking at. It's faster, more efficient, and completely alien to how we understand vision. And each eye moves independently. While one eye tracks a target, the other can be scanning the environment, and it uses all of that to line up a punch that moves faster than you can blink. The mantis shrimp's punch happens in 3 milliseconds. For reference, a human eye blink takes between 100 and 400 milliseconds. You literally cannot blink fast enough to see a mantis shrimp punch. By the time your brain registers movement, the strike is already over. But how? The secret is in the structure of its arm. The club isn't just a blunt object. It's a highly engineered piece of biological machinery. The mantis shrimp has a special spring-loaded mechanism in its appendage, kind of like a crossbow. Muscles pull back and lock the club in place, storing energy. Then, when the shrimp releases the latch, all that stored energy fires the club forward in an explosive burst. But here's the problem. If you punch something at 10,000 Gs, the recoil should destroy your arm. Every action has an equal and opposite reaction. So how does the mantis shrimp survive the impact? It has built-in shock absorbers. The club is made of a highly organized structure of chitin and minerals arranged in layers that absorb and dissipate impact forces. Scientists have studied this structure extensively because it's one of the toughest natural materials ever discovered, and they're trying to replicate it. In fact, materials scientists are actively studying mantis shrimp clubs to design better protective gear for the military. And it's not just the club. The mantis shrimp's entire exoskeleton uses similar principles. It's tough, flexible, and incredibly resistant to damage, which is important because mantis shrimp live violent lives. Mantis shrimp are viciously territorial. They claim a burrow or a crevice in the reef and defend it with extreme prejudice. If anything gets too close, they attack. It doesn't matter if it's a crab, a fish, or another mantis shrimp. It doesn't even matter if it's a camera. Yeah, I think we can confidentially say that nothing about this makes sense. Every single thing about this animal is absurd. Every feature contradicts the one before it. It's a small crustacean that acts like an apex predator. It's an aggressive brawler, It's built to destroy and built to survive its own destruction. Normal doesn't apply here. Logic doesn't apply. The mantis shrimp is what happens when evolution stops making sense and just starts experimenting. And the worst part? It works. The mantis shrimp has been around for hundreds of millions of years, almost unchanged. Whatever evolutionary insanity created this thing, it's clearly doing something right. And here's what's interesting. The mantis shrimp kept its armor, that thick reinforced exoskeleton that can absorb impacts and withstand its own punches. It's one of the few arthropods that didn't abandon protection for more speed or efficiency. And that makes you wonder, why did so many others give it up? 300 million years ago, the ocean floor was crawling with giants wrapped in shells, creatures so heavily armored, nothing could touch them. But today, their descendants are tiny, vulnerable, and soft. Evolution didn't just reduce their armor, it abandoned it completely. If you want to know why nature gave up its best defense, make sure to check out my latest video right here. It's the story of how the rules changed and the giants fell.